Assalamu alaikum students. This is our last lecture, and in which we will discuss the output of regression analysis. So this is R square. This is R is what your relationship, small r I discussed with you guys, that was correlation, and this is big R, that R square of that R. That tells you how much your model is fit. So it is 24%, even though 20 to 15% in our social sciences. In natural sciences, R square is a bit greater. Even once again, if you want to divide our business field within behavioral sciences, as we have been discussing these tests, statistical tests which we are conducting on the primary data. So on primary data, even though smaller R square is acceptable. However, in secondary data, when you are going to predict some financial data or financial considerations or financial things of a company, let's just suppose if you want to see the investment, then return on investments, like that, then you will have more R square. But within this, within primary data and within behavioral sciences, the R square is also less, R square is also acceptable. But from where you will be able to consider or see that if your model is fit. The test F test tells you, and R square tells you, F test tells you about if the model is fit or not. So this is what significant level is. Significant level less than 0.05 tells you that either it is fit or not. So what we have got 0.000, it means it is less than 0.05, so your model is fit. And how much, what is the value of F statistics? F statistics value is 7.735, means 75%. And how you need to interpret it, or how you need to discuss it, this is what these are the EFA results, this is what correlation, and this is what regression analysis. So and this is what standardized coefficients, this is correlation table. I am not going to discuss correlation table. Okay, this only R square is given here, that it is 0.27, and how you need to discuss, or what you need to say, you need to say like this and nothing more. The R square is 27% with FSS of this much. Okay, the data is the same, and why this is the difference? Actually, that I have been conducting different workshops on this data set, so this data set has been reduced, or many changes I have made, many changes while teaching to the students. So I will make some sort of changes like that. In your lectures, I made changes. I made myself somewhat aberrant values. I made some myself missing values, and then some I conducted then outlier tests. So this data set has been completely changed. That is why there's a little bit change in the statistical test. Now, you can see the F is now has been reduced. F test is now reduced. It is 75%. The original at the paper, that is 86.32, and 27% is R square, and however here's R square is 24%. So what is R square in adjusted R square? Adjusted R square, from adjusted R square, your standard error is minimized or minused So this is what you need to write. Okay, further if we want to see, we can also see from the JLab palette example. So they have this one example and how they are going to, they have discussed all these things. You can see multi-unity and each and everything, but I am not going to cover for you guys. And evaluating model, let us suppose if they are saying what is this, look at the model, box check, heading R square. This tells you how much of the variance in independent variable perceived is explained by the model. Okay, and in this case they have got 46%. So and what is this adjusted R square? You will notice an adjusted R square value in the amount when a small sample is involved. R square value is the sample tends to be rather than optimistic overestimation of the true value of a population. The adjusted R square stresses correct this value to provide a better estimate. So you can use in your stresses adjusted R square. Population. If you have a small samples, you may wish to consider reporting this value rather than normal R square. So this is how the detailed discussion is related with the model fit. After model fit, we are going towards the hypothesis, acceptance and rejection, and beta values. This is what constant is rewritten. This is beta naught. This is beta naught, and it does not tell you about the hypothesis, acceptance or rejection. However, these are the variables and their effect on dependent variable, that attitude to tablet device. And this is what beta value 1.119, and the T, this is unstandardized. You can remember that we selected both things. We selected from here, sorry, a mistake, from I think so, from save button, this one, predictors unstandardized and standardized. I check both. If I'll check only standardized, then I'll get only standardized data. This is what unstandardized coefficients, and this is standardized coefficients. The difference is what error is minimized from within standard error. My mistake, pardon me please. For standard coefficients are what, and the standard betas are what. From unstandardized, only error is minused. So you can see here the beta values. You need to report this standardized betas. So always remember, you need to report beta values which are standard. This is TEASERS, from where the level on which you are, you need to consider only this thing, either hypothesis has been rejected or not. This, if your significant value is below than 0.05, remember 0.05. If that is below than 0.05, that means this is what your 95% confidence interval. Even though there is a understanding related to this, that what do you mean by the 95% confidence, and what do you mean by the 0.05? 0.05 is what, only 5%, and 95% you are confident. Okay, so all these hypotheses as per this significant value, all these factors have impact on the dependent variable attitude to adapt tablet device. What that does mean? That means all these variables predict the dependent variable, and they have significant effect on the attitude to adapt tablet device. And within hypothesis we hypothesized that there's a positive effect. There's a positive. These are the hypotheses. Let us suppose the facilitating condition has a positive effect on attitude to tablet device and perceived like this. So we have got the result that these variables have positive effect on attitude to adapt tablet device. These independent variable predict the dependent variable. So how you need to write like this? You need to write, we will cover this here within discussion. This this is for discussing third hypothesis, so obviously the other hypothesis will be discussed in above section. From here you can see here the proposed hypotheses are tested through multiple regression. Regression is run on the retrained EFA extracted factors, and the 4 hypotheses were proposed. You can see the 4 hypotheses. These are the 4 hypotheses that were proposed, and all the hypotheses have been accepted. You can see from the results all hypotheses have been accepted. The hypothesis 1 is, this is what writing style. The hypothesis 1 is the facilitating condition. You need to write that hypothesis and you need to tell has been accepted with the p-value. P-value is what, this one which I am saying you, significant value is also said to be as the p-value, and the beta value is 0.11, and you will write standardized beta value, this one. So you will write that this is their beta value. The perceived has negative effect on like this, but we don't have any negative effect here in our analysis. So if there's a positive effect or negative effect, you need to report in the results. Likewise, you will report all these things, that this is their p-value and this is their beta value, and then you will have discussion on that. What do you mean by that, and what is, so that is another story which you will learn in your advanced classes. So this was all from the regression analysis. If you have any query, concern, anything else, you may ask. Thank you. Allah Hafiz.